Okay, so calculating theoretical probability of having three boys in a family. I'm going to use a tree diagram to model how I would go about solving this problem. So in order to set this up, what I would have is like a column of like what is the first child that's born, what is the second child that's born, and what is the third child that's born. And then I would start with my first and I would work my way across. So I'm just going to start it here and then I'm going to import an image of one that I did by hand because, as I stated last week, I find it much easier to do tree diagrams by hand rather than with the stylus. So for my first child, I have an equal chance of having a boy and a girl. So I'm just going to do B and G to represent boy and girl. For my second child, now, just because I had a boy first doesn't change the likelihood of what I'm going to have next. If I have a boy first, I still have equal chances of having a boy and a girl. And then as I move to my third child, so if I have a boy and then a boy, I still have the same chance of having a boy and a girl. And if I had a boy and then a girl, it would still be a boy and a girl each time. They would never change, or I would never get rid of any of the possible options. So I'll import this picture and we can analyze what our theoretical probability would be. Here's a tree diagram that I made for the three boys in a family problem. So I'm going to use my highlighter and I'm just going to go through and I'm going to highlight the branch that has the favorable outcome. So what I'm looking for the likelihood of having three boys. So that's this branch right here is where I'm going to have three boys. So that is the only situation that I can come up with for where I'm going to end up with three boys in our family if we've got three kids. So there's one scenario that works. Now I'm just going to go through and I'm going to highlight how many total scenarios I have. So I've got 1, 2, 3, 4, 5, 6, 7, 8. So I've got a total of 8 scenarios, 8 different combinations of what I might be able to have if we were to have three children. So if you were to have three children, you could have, for example, a boy, and then a boy, or you could have a boy, and then a girl, or you could have a boy, a girl, and then a boy, and it goes on and on. So we've got 8 different combinations, but only one of them is the situation of having three boys in the family. So I have a 1 in 8 chance, theoretically, of ending up with three boys in a family. The second part of the question asks for us to identify the favorable outcome. So the favorable outcome is what we're looking for to happen. So our favorable outcome in this problem is all boys, is having all boys. Complementary events, as we looked at in the sample from the drop zone, complementary events are all of the events that could add up to all possible events that could occur. I don't feel like I explained that well. But basically, what it is so if my desired outcome is all boys, then what is all the other possibilities? Well, all the other possibilities is um, at least one girl being born. So if I take my scenarios where I have all boys being born, so that's only one, and then I take all of the other scenarios that have at least one girl, that would be the other. So my all boys is the 1 out of 8, and at least one girl is the 7 out of 8. And if I add up 1/8 and 7/8, I end up with 8/8, which is essentially all of the possible outcomes that could occur in this situation. So that's how I know that I've got my complementary events correct, is if I'm covering every possible scenario with those two different categories.